Good morning. How are you today? Good, good. Yeah, I'm doing good. And welcome to Introduction to Psychology. Did you have a good long Labor Day weekend? Yeah, good. What are you drinking? I'm just wondering.
Red Bull.
Okay, yeah, that's the best taste energy drink, right? Okay, so we kind of stop here. Today we are going to finish chapter 2. And this week I try to do my best finish chapter 3 as well. So we can take exam 1, our first exam, kind of covering chapter 1, 2, and 3. So you had a question about how about the left-handed person versus like a right-handed person. So I kind of researched a little bit. So we talk a little bit about those hemisphere, left hemisphere, the major function of the left hemisphere. It's relating with your language production and language comprehension. So a person say certain words and try to understand. Usually, typically means like a right-handed people. We are using left hemisphere, left brain to support our brain function. But left-handed person, some people say, oh, they're very creative, more creative. Sometimes they are genius, right? Probably the process of receiving those information can be a little different. If I say right-handed people, they are using most likely more than 90% of 90% of they are using left brain to produce language and comprehension of those languages. But left-handed people, they can use other cortex area or even like a right hemisphere, try to kind of help them to produce language and comprehend the language. So for the left-handed people, we can say about even 75 to up to like 85% of the left hemisphere using for the language. Production or comprehension. Unlike right-handed people, we are almost like over 90, always like 90 and 95%. We are using left brain for our language, production and comprehension. So in conclusion, there are not much huge difference. I mean, the left-handed people are not genius. I mean, maybe the processing of those brain can be a little varied than typical right-handed people. So that was really good question. So we kind of stop here talking about is it like a softball or baseball, right? And you said maybe it's a baseball, right? So here the patient who suffer severe epilepsy, making a conclusion, maybe we can sever those between left hemisphere and right hemisphere. Do you still remember what's the thick band connecting left hemisphere and right hemisphere? It will be on your exam.
The corpus callosum.
Very good, very good. So it's pretty much thick and elastic. So imagine it's a cut. The corpus callosum is split right now. And then the visual side wise, you see only like a right visual field. Right visual field means when you see writing and right kind of vision and handing like a right hand moving, your left brain is activating. So in this case, if the person kind of asked the question, maybe I will show how does go those experiment. So a patient split brain surgery had those patient is still right here and only see the right side of the screen, kind of those screen and see, and we kind of ask, what do you see? And the patient can say it's a ball. Yeah, it's a ball. Yeah, it's a safe way, not the softball or baseball. So it's a ball. But this case, yeah, it's a ball. Got the right answer. And here, this time you show the hammer on the left vision. So left vision means because it's a totally split, and you show them only left vision, which is your right hemisphere is activating right now. And can you say, what do you see here? And the patient will say, I saw nothing. Because since right hemisphere, most typical people, we are using left hemisphere for the language comprehension and production. In the sense, it just sever means no communication, left brain and right brain. So the person even cannot, say that word and comprehend those objects. But can you draw? What do you see? They can draw the hammer. I know it's a little hard to understand, but let's do one more time here. So brain split surgery in order to prevent those seizures. So only right field kind of vision area, in the sense left hemisphere is activating. Try to figure it out. The person say banana. But when you kind of completely sever your left brain and right brain and show the banana the same thing, can you read the words? What do you see over there? Nothing. But can you draw? What do you see? They can draw. So facial recognition and overall perception, it's more, we are controlled by the right hemisphere. But I want to say, since we are not the split brain surgery, those patient, everything is communicate each other. So the key is we can compensate each other, especially maybe brain injury can happen when kids are very young. Even right hemisphere, they can take a responsibility for the language production and comprehension. So those are brain plasticity. Okay, let's keep going. Do you still have the paper? Yeah, very good, very good. So the due of this paper is this Thursday, but if you need more time, you can give me next Tuesday as well. But I believe you can kind of finish today, and by this Thursday, you can give it to me, or you can upload those. Okay, good. Yeah, you can give it to me. So here are the lobes. If you're looking at the outer side of our brain, we have 4 different lobes. So starting from the occipital lobe, can you touch your back side of your head? Yes. So when you try to like some action and try to remember, you can memorize better. So those are occipital lobe relating with your vision, and temporal lobe more like near your ears. Yeah, temporal lobe. So it's relating with your hearing. And on top of your head, which is parietal lobe. Can you touch on top of your head? Yes, parietal lobe. It's relating with your perception and sensation. Because the parietal lobe, we do have a sensory motor skills right there. And frontal lobe is really important because that makes us human being very intelligent compared to other species, and organizing skill and planning ahead and making a decision. Those are really important function. Frontal lobe right there. So frontal lobe, yeah. So we will go one by one. Basically, occipital lobe, one more time, it's a lower back part of the brain. It's relating with, involving in vision. So if you haven't finished your definition of those, this is great time. You can write if you watch my lecture right now. And those are occipital lobe. Okay. So temporal lobe, it's near your ear, temporal lobe. It's about relating with the hearing. So understanding speech, not producing speech, but it's understanding, comprehending your language. Wernicke aphasia. So I will show the next one. Finally, maybe this is time we can recognize Paul Broca. Do you remember the French, Dr. Paul Broca? His patient died after a stroke, and after autopsy, he realized certain part of the brain is broken. That's why that person could not say any word. So that's the name of Paul Broca, so Broca area. If something wrong with those area, left hemisphere of those particular area, but that's more like a frontal lobe, yeah, you cannot produce language. You cannot speak those language. But Wernicke area is right there. Those are temporal lobe, near your ears. So temporal lobe, if something wrong with those Wernicke area, you cannot comprehend language. You may say ba, da, bo, bu, bi, something like those gibberish language, but it doesn't make sense. So comprehension has a certain problem. So we call it those are Wernicke aphasia. So maybe it's wrong, it's something wrong, so you cannot comprehend the language and you cannot understand those language. But those are located with the temporal lobe, right here, temporal lobe, Wernicke area. So here, parietal lobe, those are on top of your brain, So we do have a somatosensory cortex on that parietal lobe. If you're looking at here, this is really weird, right? This is really weird. Imagine little tiny fly try to landing on your lips or maybe on your face versus little tiny fly try to land on your torso, maybe landing on your leg. Yeah, very tiny fly, right? You probably very sensitive about, those little fly try to kind of landing on near your face, right? So portionally, if you're looking at this, like that person's portion, like the lips, face, and nose, eye, those whole portion has larger amount comparing to leg and hips and torso, like a little tiny space kind of we need for the sensory motor, sensory cortex. So somatosensory cortex, it's relating with sensitivity. Yeah, those how you sense, those are relating with your sensory. So here, those are parietal lobe right here. Yeah, that's the parietal lobe because we have another motor cortex. Those are relating with the frontal lobe. So looking at the weird picture, so if something wrong with maybe this area, that means you cannot sense well your face area. So those band, yeah, those whole sensory cortex relating with where is located those sensory, receptor and try to sense those all the feelings. So I will show another one, frontal lobe. Do you still remember the frontal lobe, front part of your brain? It's really important. Underline, executive role, which means planning ahead and organizing skill and try to making a decision. Those are all the frontal lobe. Prefrontal cortex, that's especially relating with the high function of your brain. So when you are in junior high and high school, did you make some mistake? And maybe I shouldn't do that, maybe I should do that. Any regret when you're thinking about junior high and high school? Yeah, a little bit. Everybody, yes, that's the answer because prefrontal cortex, it's a really important function, making a right decision, plan ahead. And thinking about organizing whole situation is still developing when you are going through junior high and high school. Until people say 25 years old. But later research say even like 30 years old, we are still developing and developing. So prefrontal cortex is really important function, so we need to understand them. Junior high and high school going through still developing, not settled down, still improving those skills. So those are good, important function of the frontal lobe. And one thing is motor cortex. So those one was the sensory cortex. Somatosensory cortex, it's relating with the parietal lobe right here. Parietal lobe. But right before sensory cortex, those are motor cortex. Those are portion of the frontal lobe. So when you're looking at here one more time, it's a little weird, kind of portionally, but dexterability. Can you show me your index finger? Yes, very good. Try to wiggle and wiggle. Can you try to wiggle your toe? I mean, I cannot see your toe, but try to wiggle your toe. It's much harder, challenging. So in that sense, if you're looking at the fingers and hand, that portion, like a huge amount, it's relating with right there, somewhere right here, relating with the motor cortex. You can move, mobility. But if you're looking at the toes and ankle, it's a tiny right here comparing to your hands and finger. So how much you can move, like a motor cortex relating with your frontal lobe, that's the motor cortex area. It's belong to frontal lobe. So speaking area, one more time, it's somewhere relating right there. Paul Broca find it out. Those are Broca area. If something wrong with that, which is Broca aphasia, you cannot speak. You cannot produce the language. So that was an interesting fact. So when you're thinking about, so far actually, we kind of covered all the functions of brain activities while you are driving. Cerebellum and medulla and reticular formation, thalamus, hypothalamus, and amygdala, hippocampus, corpus callosum, and frontal lobe, parietal lobe, occipital lobe and temporal lobe. So far we kind of go one by one. Daniel, you feel like a confident now and try at least.
Not in memory of it. I'm definitely going to have to study before the quiz.
Uh-huh.
I'm also going to ask, with the quiz, do we have any sort of study guide to go off of, or do we? Just
It's
have one
already
on our
it's
net?
already there. So
already on
if
there?
you look, do you know how to go to Blackboard?
Yes, ma'am.
Yeah. So if you go to Blackboard, I always put my PowerPoint, so you can kind of check my PowerPoint, and also I put the study guide for the exam one, so you can kind of study. And for the yeah, so please check on that. And exam one, all the exam is online. So that means it's open book. So if you have a textbook, and so far you've been attending my class, 100%. So during my lecture, I can this will be on your exam, and yeah, underline. So if you have be ready the PowerPoint and those extra information. If you have a textbook, it's kind of easy to try to find the answers. But time is limited, so you do better study before, and then you can kind of timely finish those exam. Okay, good. So here, let's check on, here, cerebellum. What's the function of cerebellum, if you don't mind?
Balance and coordination, it makes up 10% of the brain.
Yeah, and I heard your friend got some, like a certain part
Yeah,
kind of
traumatic
broken.
brain
Yeah, injury
lost
after
some of the
that.
balance and stuff.
Yeah. So maybe remember cerebellum, after that it's really hard to make a good balance, yeah? And keep kind of moving like a swimming, and maybe keep kind of moving the same movement. Initiation is relating with motor cortex, which is frontal lobe, but keep kind of bicycling, maybe swimming. It's a function of the cerebellum. Very good. How about the medulla? It will be on your exam.
Life-sustaining, breathing, swallowing, heart rate,
Yes,
stuff like that.
yes, very good. So it's a brain stem, kind of hind brain, but it's a really important function. You feel like maybe it's not for, like a upper part of the brain, but still as a part of the brain stem, those are really important. How about reticular formation? Yeah.
Hearing and reaction time, waking up, general attention to things.
Yes, I still remember Daniel is sensitive, so even like a doorknob sound, maybe you can wake up, so you don't need to have those alarm clocks. So if you remember those, probably you have a very sensitive reticular formation. So thank you. How about thalamus?
It's your center process center. It doesn't deal with your smelling, but it does with your sensory processing, attention, and movement.
Very good, very good. We did like an index finger and try to reach, in the middle part. So you will kind of touch those thalamus. When you touch, when you hear, when you see, everything is first sensory center, which is thalamus, and sending those signals to the upper part of your brain. How about hypothalamus, which is under thalamus, hypothalamus?
It'd be your hunger, thirst, sexual drive.
Yeah, and try to make our body more homeostasis, like a more comfortable state. Yeah, if you're too hungry, you cannot concentrate on, and you wanna eat, grab some food, right? So kind of give us some signal about those basic our needs. How about amygdala?
Fear.
Yeah, fear. It's an emotion and motivation relating with that. So maybe if you're really fearful and anxious all the time, part of the reason is maybe amygdala is activating too much, like sensitively, but there are so many other reasons why you suffer some anxiety and some fearful emotion. So we cannot say, oh, it's because of the amygdala, but major portion and function of amygdala is relating with your fear and motivation. How about hippocampus? You need to remember at least one thing. Yeah, hippocampus.
Learning, long-term memory.
Yes. Yeah, do you still remember the Henry Molaison, HM, those story? I kind of ask you to read those.
A little bit.
Yes,
I've
yeah.
slept since then, but I remember.
Yeah, so Henry Molaison, after removed the hippocampus area, he could not make a new memory. So every day, doctors and nurses, they need to introduce themselves. Hello, my name is Sarah Munso. I'm your doctor. And try to communicate with you because hand immolation cannot make a new memory at all after removing those hippocampus area. Okay, how about corpus callosum? It will be on your exam, corpus callosum.
Separates the two brain hemispheres and allows them to communicate between each other.
Yes, yes. Those are kind of connecting part. Thick band, the connecting part. Very good. How about frontal lobe? Frontal lobe. Like a frontal lobe?
Thinking and planning.
Uh-huh.
It's the executive role.
Very good, very good. Yes. How about parietal lobe on top of your brain? Parietal lobe?
Your touch and reception.
Okay, very good. How about occipital lobe, back side of your hemisphere right here?
Your vision.
Yeah, your vision. How about temporal lobe near your ears?
Your hearing.
Yes, yes, very good. So far we tried to cover all the major function of each brain, but I want to tell you all our brain inside, it's all interconnected, which means sometimes it can compensate each other, those function, but those are like a major kind of definition-wise. If you remember at least like this one, maybe later on you can kind of connect and maybe extend more knowledge based on this. So backside, I know some of you already submitted your story through the Blackboard. I check on that during weekend. But if you haven't done it, this is great chance. Take your time. Maybe go to somewhere else. Maybe you can set up the destination. I will go to Oklahoma City. I will go to Tulsa Zoo. I will go to Universal Studio. I will go to New York City. Yeah, we kind of through some imagination, set up the destination, thinking about road trip. I know you are a high schooler, you cannot drive yet, some of you. In that case, thinking about you're sitting right next to your mom or dad and try to go together and plan together, going some road trip. Okay, so I will give you a little bit of time. And since Daniel wrote his story, we want to hear from him. Is it okay, Daniel?
That's fine.
Okay, good.
They kind of all, like you said, they kind of all intertwine. So like, I might have written one part of the brain, but it obviously will go over a couple different ones.
Sure. Yeah, that's what I mean about everything is interconnected.
Yeah.
There's not only one function of each brain. Yeah, so thank you so much, Danielle.
And I also didn't go into like crazy detail, but you want me to go ahead and start?
Yeah, so where are you going? Your destination?
Okay, so I didn't choose a specific mountain, but I chose just driving a road trip to a mountain or down a mountain in Colorado.
Okay, yeah. Yeah, I love go to Colorado, so I'm excited.
I'm not the best writer, so I just kind of threw something together.
Okay.
All right, so I had planned on going on this incredible road trip for a while now, and then that would be your frontal lobe. And only now did I finally have the time and money to do it. It is a very scenic route down a beautiful mountain in Colorado. As I was driving, I rolled down my window in order to feel the nice, cool breeze, which the parietal lobe and the thalamus. Although cool, the breeze only reminded me of how thirsty I was. Hypothalamus.
Very good.
Medulla. I grab my water bottle and take a sip, then proceed to steer my car around the mountain's curves. The cerebellum.
Very good.
I would drive faster, but I'm afraid of these mountainous roads and just continue soaking in the jaw-dropping view. Amygdala,
yes.
As far as I can remember, not too many people die because they drove slow and methodically. Hippocampus.
Okay.
If you ever get a chance to drive down a Colorado mountain, do it. Yeah, it's just the short something I wrote.
Yes, very good. I really appreciate you.
No
so
problem.
you can give it to me. I will give you back to this Thursday. Okay, thank you.
No problem.
Okay. Thank you so much. Thank you. So if you are done already putting the definition of each function of a brain and you wrote your own story, maybe you can take a picture and upload, or you can upload your document, like a Word document, either both sides. Yeah. So I will check for that. The due date is this Thursday, so you have a time. But I'm so glad we can make our own story. So Daniel, you feel like you can remember a little, at least like some
Oh, I
part
can
of the
definitely
brain.
a lot more than before.
Yeah, yeah.
Did I happen to put my name and stuff on there? Everything required?
Yes,
Okay,
you did.
just
You did a
making
great
sure.
job. Yeah, perfect. Yeah, thank you so much.
No problem.
So, I mean, we do have a little bit of things we can cover more about brain and connection, like the central nervous system and peripheral nervous system today. So I'm kind of been hoping finishing this chapter today. So here, what happened in your brain when you watch movies and TV? So imagine, Daniel, do you like watching TV and movie?
Mm-hmm.
Yeah. So in our brain, we try to understand the situation because let's imagine you are watching movie. You do hear sound. You do see certain scenes and maybe some very scary scene. How about your amygdala? Even though you are not going through, as a human being, our brain try to understand the situation and you feel like the same fear. So amygdala is activating. It's a normal process of our brain. So as a kid, if you watch too much TV, researchers kind of find it out. Those frontal lobe is thicker than, kids do not watch TV that, for a long time. And it can be relating with some lower function of intellectual development. So we know TV and all the multimedia, those researches, it can be used in a good purpose. But at the same time, as a little kids, they'd better go outside and spend time with nature and, play with the ball, instead of watching TV and sitting down and having popcorn or certain maybe snacks, right? So that's good to know. And another thing is brain plasticity. So brain plasticity is if something happened to your brain, maybe injury, some accident, if it is happened for young age, like a childhood and at least like an elementary school period, your other part of brain will compensate that function. Let's say you have some damage on your left hemisphere. You used to speak well, but somehow it's all, damaged. But maybe you to try to practice language and listen. And right now, maybe right hemisphere take responsibility about language production and comprehension. Those are brain plasticity. So which is really awesome. Our brain connect each other and working together. So certain brain function does not work at that moment, but after practice, like a training, the other side of brain, it does have the similar function. So which is really great. Yes?
Is that how like the memory works? You know how people train their memory? Does memory actually does that part of the brain get better over time when you practice your memory like it does?
Yeah, so it's relating with maybe if you have a certain damage of a brain part, memory is relating with the hippocampus, right?
Mm-hmm.
And also memory can be relating with the cortex area too. So I want to say when we say, memory, that's relating with the hippocampus because we memorize in that way. But memory function does relating with not only those hippocampus, also the cortex area, overall the cortex area of our brain. So there are lots of other, areas kind of supporting those memory function. Mm-hmm. So it's really hard to say when you kind of keep memorize and try to understand more and more. Of course, you can maybe clearly understand and maybe remember better, but it's more complicated than that. Mm-hmm. And chapter 5, we are going to talk about memory. Long-term memory, short-term memory, how does it work? Yeah, so maybe at that time, maybe we can kind of understand better about the memory part. But I do agree, if you try to keep, remember certain fact and overall, maybe it can recover, but maybe not. Mm-hmm. Because, those are like Henry Molaison. Henry Molaison, after he removed those hippocampus area, many doctors and researchers and nurses, they tried to help him to form a new memory. But honestly, until he died, he couldn't, even though they put lots of effort to that. So I cannot say it does, but it's a part of that. It can be working in that way. But it's really depending on the individual, how hardly they got injured, those memory area. Yeah. Okay. So maybe it's certain things happen for your memory portion, or maybe certain activities in your brain. If something happened in the earlier stages, it's easy to recover those brain function. So neurogenesis, it's a creating of new neurons. Of course, it's happened for the young children more, but still, when you get older, like a fully grown adult, we can still generate new neurons, but much slowly than young kids. So this is interesting. If you're looking at the A versus B, Daniel, which picture you feel good? You feel like I like that one. So A is more kind of polite, more like putting their hands together and try to bow down, and B is more like a confident. Can you do that? Like a confident? Yeah, confident, because you're doing right now. Confidence, yeah, Daniel, right here. Yeah, so confidence, more like a confidence, like a Superman, like a confidence, right? Yeah.
Number A looks more shy and bashful.
Okay. So if you're kind of looking at A and B, which picture, maybe which person you feel like a better? Better means maybe I would like to be A. Maybe position-wise, B, yeah. Which one you feel like more kind of satisfied? A versus B?
Probably B would probably be the best.
Okay, very good, very good. So researchers kind of find it out, inside the brain, if you're growing up in collectivistic culture, which is like an Asian country, and maybe more kind of emphasizing some like a family bonding and group value, if you're kind of growing up in that more collectivistic culture, they prefer to looking at the A position because they feel more comfortable and more like rewarding, and maybe that's the way we need to do, like something like a politeness. And B is if you're kind of growing up individual culture, which is us, the United States and Canada and European country, more like I feel more confident. I like that one. I want to be like that person instead of more like humbling, that kind of a position. But I realize it's really depending on the person. But one thing I want to share, if you are very anxious in front of a big presentation, maybe go to some place nobody can see you, and if you do like a Superman position, can you try to do like a Superman position like me? Yes, kind of putting like a Superman, like putting your right hand and then your kind of left hand like right here on your waist, and I can do it. I feel okay. So if you kind of hold those positions for 30 seconds and go back to your presentation room, somehow you boost it. You're kind of in a motivation and you feel like confident, I can do it. So those, like a motion, kind of putting your right hand, that means I can do it, more like, this, I got this, right? And putting like a more confident position, more like a B position, kind of make you more comfortable. Try to be more confident in front of the people. So I know maybe you are in maybe some big conference room, or maybe you are presenting in front of maybe interview session. You cannot do like this in the aisle, but you can go to a restroom and then you do that position for 30 seconds and then come back. And there are researches done. You may feel much better and calm down. Yeah. So Daniel, it may be something maybe you really need to present, very important, your presentation in front of lots of people. Would you like to try maybe Superman position? I got this. I can do this.
I'll try it, see if it changes it.
Yeah, maybe not everybody, but if you believe in that way, it can help. Yeah. Okay, good. So let's talk about our nervous system this time. We've been talking about one neuron. Tiny neuron that was here. I brought my neuron, and then after that big portion was brain. So now we become more expert, at least to know about basic stuff about the brain, and now we want to know overall how our nervous system is working. So our goal is we want to memorize the whole chart today. I will help you. So thinking about the nervous system, on top, nervous system, we do have two systems, CNS, CNS. What does the CNS stand for?
Central nervous system.
Very good, very good. That's the left side. I'm just like a try because we are going to memorize this one. Central nervous system. So central, when I say central, what does come to into your mind? Central.
Like headquarters.
Yes, very important, right? Yeah. CNS, central nervous system, we do have brain and spinal cord. So spinal cord, brain and spinal cord. And the other side, PNS. What does the PNS stand for?
Peripheral nervous system.
Very good. So when you're kind of making a little butterfly, peripheral nervous system, so except your brain and spinal cord, rest of all the other part is peripheral nervous system. Yeah, so we do have a central nervous system and peripheral nervous system. We already studied about brain, yeah, and spinal cord. Try to connect each other, and reflex will happen in the spinal cord, right? And the other side, peripheral nervous system, we do have a two system. Somatic system, somatic nervous system, and autonomic nervous system. Somatic nervous system, we already talked together. Everybody, can you touch your desk? Yeah. So you touched it, and this is really little hard, and those sensation, sending those signal to your brain. Access, right? Yeah. Those are afferent. So afferent sensory system carries those messages to your brain, access to your brain, afferent. And your brain kind of commands you, Sarah, it's really sharp and hard. Do not touch too harsh. Yeah. So sending those signals to your muscle and gland, afferent. So we talk about afferent and afferent, right? Those are motor, the somatic nervous system. It does have motor system and sensory system. When you touch, when you see, when you hear, yeah, try to send those signals to your brain, access to your brain, yeah, those are sensory system. And your brain will command you move your body and hands, yeah, and leg, those are motor system. So sensory system and motor system, it's under somatic nervous system. Basically, you can freely move your body. Yeah. But the other side, the name is autonomic nervous system. When I say autonomic, what comes into your mind? Automatic, yeah. We cannot control pupil dilation and heartbeat going up, yeah, sweating. We cannot control. Maybe we wish that, please, down your heartbeat. It's nothing, but sometimes it just kind of go up and up so quickly, right? So those are relating with regulate your gland and blood vessel, so pupil dilation and digestion system, and blood pressure too. Sympathetic division and parasympathetic division. So sympathetic division is when you are in very anxious moment, life-threatening moment. You need to make a decision, fight or flight. Very stressful situation. Daniel, have you ever in the situation, very stressful moment, you need to make a decision, fight or flight? I bet you do because you went through, your army, right? Yeah. So I don't want to kind of trigger any your maybe some maybe sad. It can be sad and hard moment, but that's the moment. Like a sympathetic nervous system is activating. Yeah. I have a good example, so I will share with you soon. And the other one is parasympathetic division. More like it was okay. Eventually, it was not a huge big thing, so I'm relaxed right now. Maybe digest and maybe relax. Those are parasympathetic division. So under autonomic nervous system, we have a sympathetic division, kind of life-threatening situation, and your body is prepared all the energy toward the fight or flight. Versus the other one is parasympathetic. Parasympathetic division is now it's okay, and maybe go back to your normal state, and maybe it's time to eat your food because it's all done, everything is good, right? Okay, are you ready to memorize? Let's do it. Let's do it. So this is like a nervous system. When you're thinking about nervous system on top, we do have a two system. CNS. What does CNS stand for?
Central nervous system.
Okay, so under central nervous system, we have two things. Your brain and spinal cord. Very good. And the other side, we do see like a PNS. What does the PNS stand for?
Peripheral?
Yes, peripheral nervous system. So you're kind of looking at the butterfly, imagine butterfly, all the, like except your brain and spinal cord, all the connecting part, those are peripheral nervous system. So under peripheral nervous system, we do have two system. Two system, yeah. One is?
I don't know. I forgot.
Yeah, so we can kind of go back, click on here. Oh, sorry. Yeah. So under that somatic nervous system, somatic is freely you can move your body, somatic system. When you touch, when you taste, when you hear, you can move your body, right? Those are relating with your sensory system and motor system. Under that, those are somatic system, somatic nervous system. And the other way is autonomic nervous system, automatic. You cannot control your pupil dilation and, like a breathing and those digestion system, blood pressure, you cannot, control. Those are autonomic nervous system. Under the autonomic nervous system, sympathetic nervous system, when you are in life-threatening situation, like your pupil and all the your bodily symptom. So I will go over here. Yeah, those are sympathetic, and the other one is parasympathetic. So here, let's go one by one. So nervous system, still we can kind of imagine the left side, the CNS, central nervous system. We've been talking about brain a lot so far, right? And the other part was spinal cord, which is a long bundle of neurons and carry the message from the body to the brain. Reflex, lots of reflex will happen. Peripheral nervous system, the other side, peripheral nervous system, yeah. And except brain and spinal cord, it's throughout contain all the information and communicate to each other. So under that, we do have two systems. Somatic nervous system. I know Daniel tried to write down, those are moving your hands. It's relating with the somatic system. Somatic, right? Because autonomic nervous system is your digestion, pupil dilation, and also blood pressure. You cannot control. Those are autonomic nervous system. Autonomic nervous system. So we will go one by one, very detailed information about under the somatic nervous system. Example is taking notes in class because you're intentionally moving your hands and try to write certain information. Right now you are using somatic nervous system. Right? And the other one is autonomic nervous system, automatic. Digesting your last meal, pupil dilation and sweating. Those are more like an autonomic nervous system. So those are peripheral nervous system, PNS. Yeah. Okay, so let's go autonomic nervous system. Under the autonomic nervous system, we do have two systems, sympathetic division and parasympathetic division. So sympathetic division right here, big dog is approaching to you. Daniel, do you like dogs?
I love them.
You love them? Mm-hmm. Big dog, small dog, it doesn't matter to you. You do not scare?
I would rather a big dog. Chihuahuas scare me more than big dogs.
Really?
Little tiny dogs.
Chihuahua
Yeah,
is
they're
tiny.
more
Okay. I mean, honestly, maybe I need to tell you, I have like a little phobia of dogs because when I was like a little kid, maybe around 5 years old, maybe big dog. For me, it was really big dog. Maybe golden retriever side. I was playing outside, and the golden retriever dog, approached to me, and maybe probably not to harm me, but it was too close and tried. Actually, in a bite. So I was bitten by. I do not know the name of the dog, but I got a little phobia after that. So whenever I see the dog, that dog is cute, even Chihuahua, maybe, but that dog can bite me. They have like a little, but now I have much better. I have a colleague who used to have 5 dogs, and sometimes she brought her dogs at the office. So now I can touch and maybe I can, cuddle and all things, but used to not to. I just kind of, smiling, but inside I'm scared.
More a cat person.
I don't know the cat person. But those are sympathetic division. Imagine, I know since you love dog and do not afraid at all, maybe that's more like me. Okay, so big dog try to approach you. I mean, honestly, big dog try to approach me right now. I feel really scared. Yeah. So here, that moment, your eyes, kind of widen. What's going on? So imagine very scary animal try to approach to you. So I know you, Daniel, you love dogs. So probably tiger or maybe lion, maybe big bear.
All it takes is the wrong dog not to be scared of it.
Okay. So maybe big bear, maybe because you went to Colorado, and maybe big bear, white bear, try to approach you. So that moment, imagine big bear is approaching to you. That moment, your eye pupil is going kind of bigger. What's going on to me? Is it real? Yeah. So your pupil, dilate, kind of widen and widen. Your lung increase your breath rate, kind of. What's wrong with this situation? What's going on? Yeah. So kind of lung capacity kind of increase and heartbeat goes up and up and up because the bear seems like really like you and try to approach you because you are eating some food. Yeah. So those are heart rate goes up, stomach and intestine kind of stop, slow down because this is not the time to keep eating your food. You kind of stop. And pupil dilating, big eyes, and then lung is kind of capacity kind of increased, and digestion system is kind of slow down, And skin, you have a sweating because it's too scary. Big bear is approaching to you. So those are sympathetic division, life-threatening situation. What would you do, Daniel? Big bear is approaching to you.
Spray it in the face with bear spray.
Okay.
Because I ain't on it, because that's not what you're supposed to do.
So try to use your brain, frontal lobe, making a quick decision. Mm-hmm. I have a spray in my backpack. So kind of using those spray and try to apply for the bear, right? Yeah, very good, very good. And then you realize somehow the spray works, And bear suddenly turn his body or maybe her body and try to go to a different direction. Now it's a parasympathetic division. Phew, I'm alive. I got, rescued, right? So that moment, your pupil kind of constrict, narrow your pupil, like your small eyes. And lung, decrease your breath, and heart rate is kind of decrease. It's okay. Everything is went down. Everything is good. And stomach, and I'm hungry because I kind of put my all the energy, try to find my spray and spray to the bear, and now I kind of rescued by myself, and I feel hungry right now. Hypothalamus, making a good homeostasis, give you some signal of I'm hungry. I need more energy right now because I spent too much energy dealing with the bear, right? So those are stomach, resume digestion. You can eat more food. And skin, deactivate those sweating. You become normal. So imagine if you have lots of chronological stress, always kind of up, kind of tighten, and more like a sympathetic nervous system is activating, maybe that's not good for you, right? Because always you are kind of be ready. I mean, it can be part of your job. Imagine like a firefighter. They are always be ready and very tense the emotion sometimes because they're ready to kind of go to their place, certain place and extinguish the fire, right? So you may develop those, some like a stressful situation chronologically. But try to be more relaxed. Parasympathetic nervous system is activating to your body. But we cannot control our whole life, but it is possible. It is possible. Try to more kind of, breathing down and not too much like increasing your heart rate. So try to be more like a parasympathetic life, which is like breathing out, like a when you have like a very emergent situation, try to kind of exhale your kind of breath. It's much better than always like up, like be ready and then sweating and like a widen your pupil. So we will talk more about those in a sympathetic nervous system and parasympathetic nervous system later chapter, but that's really important concept. Okay, so there was an autonomic nervous system. You do not control, but body will react for certain situation. Sympathetic nervous system versus parasympathetic nervous system. Okay. So endocrine system, we've been talking about neurotransmitters chemically deliver the message from one neuron to another neuron. But right now, we are not talking about hormones. Yeah, I know some of you may have some hormone issues. Yeah, so you need to control and checking those level of hormone. So we do have a lot of gland. And location can be a little different. Pituitary gland. Underline. Those are hormones are chemical messengers. Pituitary gland, it's our master gland. Control other gland and produce human growth hormone. So people say we need to go back to sleep at least like between 10 to 3 a.m. Maybe those growth hormone will be released during those time. So I know Daniel having pretty good like a sleeping schedule. What time do you go to bed? I remember 9?
Last night I went to bed at 10, but yeah.
10? Yeah, usually 9.
9 to 10.
Yeah, because you have a very early class, like 8:30, right? And you leave like 1 hour, apart from this camp.
About 7 o'clock.
Yeah, it can be really challenging for me because leave at 7 o'clock means you need to prepare everything, like comb your hair by at least like maybe 6:30, and then eat. Oh yeah, and eat certain maybe a little bit of light food, yeah, and then be ready and drive here. So pituitary gland, it's a master gland and relating with your growth hormone. So underline pituitary gland, it's a kind of control all the gland, make sure your body has a good communicating those chemical messengers and relating with the human growth hormone. Pineal gland, it's on your brain, produce melatonin. Daniel, have you ever maybe suffered certain, maybe you cannot sleep well? Yeah.
I've taken melatonin before.
Oh, okay. So actually our body release melatonin at the nighttime.
Mm-hmm.
Yeah. Yeah, natural sleep. So most of people, maybe if you don't have any sleeping problem, at nighttime, secreting those melatonin, from our body. So you feel sleepy and then go back to bed, right? In the morning, the bright sunshine outside, your body, in your brain, sensitive to the light, and then wake you up. This is time to get up. Yeah, bright sunshine is outside. This is like a morning time. So stop secreting melatonin. So you can get up quickly in the morning time. Those part is pineal gland and control and produce your melatonin and influence your sleep and wake cycle. So we will talk about those sleeping and dreaming later chapters. So we will talk more detailed information. How does your brain function relating with those melatonin, secreting melatonin and stop melatonin. But Daniel, when you take those melatonin as a little maybe pill or maybe gummy, was it working? Yeah.
It depends on the situation.
Okay.
I mean, I've been to the point to where like I've taken melatonin and still not slept all night long because my brain was just
keep
running. But at time, if I don't have like a brain that's running nonstop, then it'll work.
Okay, yeah. So most of like a light sleeping problem, if they take the melatonin, it does work. Yeah. But hopefully you can have a good those sleep and wake cycle, so you don't need to take. But remember, human body, you can produce melatonin at nighttime, so naturally you can go back to sleep. So do not engage too much of those screen time. That will hinder. They will hinder your sleeping and those wake up, those cycle too. So we'll talk about those concepts later chapter more in detail. So thyroid relating with their metabolism. Some of them, they have a really hard time adjusting right amount of medicine to adjust those metabolic system, having some thyroid problem. And adrenal, which is kidney, produce adrenaline and other hormones relating with stress. fight or flight. Those are right upper part of your kidney and releasing those adrenal. And males and females and ovary for the females and testes in the male, more reproductive system. It's a produce testosterone and estrogen and relating with your sexual development. It's more like actively releasing and during those puberty area, puberty period. So we will talk more about when we talk about puberty and adolescent development. But gently touching all the gland system and also nervous system and those brain function. So here pituitary gland, one more time, human growth hormone is releasing and control other gland, pituitary gland. Underline, it will be on your exam. What's the name of the gland? Control the other gland relating with the human growth hormone. That's the pituitary gland. And adrenal gland relating with the stress kind of hormone, relating with those stress, relating with those adrenaline and epinephrine. So those are adrenaline gland. So this is like a last part of this chapter. We will kind of try to understand the inside the brain, overview of how we view the brain. Imagine chapter 1, history. What's the historical kind of background of psychology? We talk about two those philosophy area. One is philosophy and the other one is physiology, right? It will be on your exam too. Okay, so Daniel, maybe this is time. What is psychology?
The scientific study of the brain and personality. I don't know.
Yeah. Very good. Scientific study of mind and behavior. Anything like a mind and behavior. Yes, very good. Yeah, those are number 1 question, by the way. So you already got this, right? Yeah. So inside the brain, we want to see and look more, but we do not have any function like MRI and like a PET scan and anything else. But now everything is available, and we can kind of investigate more inside the brain what's really going on when you eat, when you think about maybe your favorite movie, when you're thinking about your boyfriend and girlfriend, what's really activating inside your brain, now we can tell. So here we are going to talk about EEG, electroencephalography, and computed tomography, CT, and MRI, and PET, and functional MRI. Have you ever heard here and there EEG, CT, X-ray, at least like X-ray, MRI, PET, and functional MRI?
Couple of them.
Yeah, couple of those. Yes. So we will go kind of one by one from here in this kind of part. So electroencephalography, EEG. It's a little device. Even infant, they can wear it. They can wear those little device. And if you have some sleeping problem, maybe doctor recommends you maybe let's check EEG. So while you are sleeping, you are kind of wearing those device, and it will check the brain wave. Brain activity, and detect your brain wave. And if you have a deep sleep, maybe some shallow sleep, and try to check your whole sleeping pattern. Those are wearing outside. So even like an infant, they can wear those in a device, and they can move, but still kind of checking their brain wave. The second one is a CT. Maybe if you broke your arm right here, maybe go see a doctor, and doctor maybe command the nurse, maybe please take some like X-ray. Yeah, X-ray is you commonly kind of heard if you broke your arm and leg, right? Oh, somehow it's really complicated. X-ray doesn't show the detailed information. Let's take maybe CT. Yeah, so CT is more detect like a structure, and more detect structure you can kind of see comparing to X-ray. So 3D X-ray that detect those structure. Yeah, so EEG more like activity, and CT is like a structure, more detailed. And MRI and PET. MRI, you can kind of see the different color of the portion of your brain, and you can see the structure, which area may be less kind of sensitive comparing to other area. So based on those structure, we may kind of assume there's some like a little tumor going on, or maybe it's gonna be okay. Yeah, it looks like it's totally okay. Yeah, so they're gonna kind of detect brain structure through those MRI, magnetic field. The PET underline, PET is a little different. PET, underline PET, and functional MRI, those are a little different because you can detect function. You can detect function. So when you, the brain, so radioactive sugar is injected into body, yeah. And after that, brain uses those sugar and they kind of show activity of your brain. So inside, more active area has more bright color usually. So using more sugar, so kind of see which area is activating more. So it will show not the kind of structure, yeah, structure of kind of 2D, but it's more like a function, which area is more activating. So those are PET. Yeah, PET, remember PET, you can see not only those structure, you can see the functions of the brain. So this is interesting, murderer's mind. If you're thinking about serial killers and murder, using those PET scan, yeah, brain PET scan, putting the radioactive ingredient inside of the body and try to see the brain, kind of researchers realize murderers showing more overactive limbic system. So limbic system is those area, thalamus, hypothalamus, amygdala, and hippocampus. Those middle part of our brain relating with your emotion and motivation is overactive. Somehow very sensitive, overactive. So maybe somebody tried to maybe accidentally kind of hit you, but you feel like, oh, that's that person's accident. I understand, right? But maybe those people are very sensitive and react overactive. So that means it was even like an accident. That person kind of received that as a try to harm you. Yeah. So murderer's brain, those limbic system is overactive and underactive prefrontal cortex. Do you still remember the function of prefrontal cortex?
Decision making and personality?
Yeah, very good. This is the making and plan and organizing skill. So those part is lacking. So imagine your, revenge, kind of, fearful emotion is overactive. But making a decision and try to understand the situation, oh, there was a person's accident. Yeah, instead of that, maybe that person tried to kill you. Yeah, if you understand in that way, yeah. So those are more like a murderers inside of their brain. They're kind of happening through those PET scan. Okay. So here, those are functional MRI, underline. Those are most advanced level of brain, investigation inside of our brain. Functional magnetic resonance imaging, functional MRI, fMRI. Maybe you hear here and there, fMRI. So MRI is more like an X-ray. You can see the structure, but functional MRI and PET scan, those are different. Underline, PET scan and functional MRI, you can see the activity of inside the brain, more like a function of the brain, not only the structure. Yeah, it's kind of moving. Still kind of give us those sense of what portion of brain is activating. So relatively new technology, but because of those PET scan and functional MRI, we recognize which area is activating more sensitively. Even you can kind of compare this week and maybe in 2 weeks, and in 2 weeks, certain part of brain is more activating after injected a certain medicine. So you can kind of see, and right now, kind of using those device, what kind of thinking going on, negative thinking, positive thinking, which area is brain is activating, more activating. You can kind of compare and see. So we are going to watch a short YouTube about those functional MRI, and it's going to be all done this chapter soon. Okay, good? Okay. So we will watch video clip.
Technology are changing the way we understand brain activity and diagnosing potentially deadly mental health disorders. Suicide is one of the leading causes of death in the United States, according to the CDC. As part of Mental Health Awareness Month, Nikki Batiste shows us how researchers are using brain scans to spot harmful thoughts. Nikki, good morning.
Good morning, Don. Good morning, everyone. We visited Carnegie Mellon University to take a look at research led by psychology professor Dr. Marcel Just. He spent decades developing a sophisticated system to try and read our minds. And now he's making a breakthrough into suicidal thinking.
We found that there were certain concepts that were altered in people who thought about suicide. And our method was able to detect those differences and analyze exactly what the differences consist of.
That method begins with a sophisticated piece of equipment, a functional MRI.
With fMRI, you see a picture of the brain's activities.
So you're saying every thought idea in our brain has its own specific pattern?
Yes. And what's really, I think, fascinating and relatively new is the patterns are similar across people.
Unless you have suicidal thoughts, then they're altered.
That's what psychiatric illnesses do. They change the way you think, and this method can, I think, identify those changes.
These images show two people thinking about the word death. This one has thought about suicide, this one has not. The colors represent brain neurons.
When you see dark blue, that means very little firing.
And the red is telling you
That you get activation related to self-thinking when they're thinking about death. But among people who have made an attempt, you see even more of this dark red.
34 people took part in his latest study. 17 of them never had suicidal thoughts, but the other 17 had. And over half of those 17 had even attempted suicide in the past. These second-by-second snapshots show clear differences in the brain patterns when the participants were asked to think about different concepts like carefree, praise, and death. This is
our thought library.
Those snapshots were then analyzed by this complex computer server, storing hundreds of thoughts by hundreds of people with the power to search for unique patterns.
We can tell whether somebody's feeling anger or happiness or sadness. We can tell what number a person's thinking. We can tell what topic a person is reading a paragraph about.
Dr. Just's method was 90% accurate in determining who had past suicidal thoughts and attempts. How might Dr. Just's research change the future of suicide?
If we could understand the neurobiology underlying the drive to harm oneself, then we would be able to design better therapies aimed at reducing that desire. The treatments that we have now don't work all that well.
Dr. Joshua Gordon, director of the National Institute of Mental Health, thinks Dr. Just's work could lead to more effective treatment. So potentially in 10 years, I might go to the doctor's office, electrodes are put on my brain. They will be able to tell whether I have a mental illness, whether I'm suicidal. Possibly.
It's slightly optimistic, but not impossible, maybe 20 years.
The National Institute of Mental Health recently awarded Dr. Just and his team a $3.8 million grant to continue their research. They have already proven their method works to identify autism spectrum disorder. In the future, Dr. Just hopes to apply his approach to other psychiatric disorders like depression, schizophrenia, and bipolar disorder. Such amazing work they're doing.
Okay, so that was pretty much about the whole this video clip. I will go back to. So you feel like this is a really amazing stage right now. Just looking at the inside the brain using functional MRI, certain area is kind of more red color comparing to other area. So we kind of recognize suicide ideation. Well, maybe that person has more. Seems like having those thoughts. So try to prevent before happening and also kind of helping those people. So that was interesting, but I want to ask you, since we do have a high technology and now we can see inside the brain, that means we should totally trust those information because it can be, maybe wrong diagnosed. Yeah, just looking at the inside the brain, itself, we need to talk to that person and try to thinking about those environment and maybe individual difference. We need to consider those. But that's really interesting. So this is like our last kind of slide of this chapter. So we will do together complication of contralateral wiring. So I know the pair of, maybe Daniel and me, we can do together. And if you're watching this lecture, you can do together who is maybe listening together. So one person will be experimenter and the other will be the subject. Here is the procedure. So, but we are going to take a turn those roles. So if you are watching me, pair up and one person will be experiment. So number one, starting from number one, let's follow. Subject should extend both arms. Can you do? Yeah, both arms in front of the body, straight out and parallel to one another. Yes. And rotate hand so the palms face away from one another and cross hand. So far, so good. Yeah. Cross hand over and claps like a palm to palm. Then, then rotate arms. Yes, very good. It can be a little challenging, but we can do it. And yes, very good. Yes. So here, I will point your finger. So the key point is you do not touch that finger, but kind of point. So can you wiggle that finger? So let's see yours first. Can you show me your fingers? I mean, you need to do like the same thing like here. Yeah, can do a little. Yes. So maybe you can like this, and then here. That's the procedure. So here parallel, and try to palm away, and cross hands over, and claps. Then rotate the arms. I know it can be a little challenging. Yes. So can you wiggle this finger for me? Can you wiggle this finger? Yeah. So can you wiggle this finger?
I don't know which one.
So here, maybe I will cross my fingers, and you can point. I try to wiggle my fingers. So do not point.
Oh, do not point?
Yeah, I mean, do not touch. Do not touch. Sorry, but point. Oh, okay. It takes time. Oh
yeah,
no. Okay. Yes. So we do not have those position often, but this is like a little game. But you can do with maybe your brother and sister and your family. It can be fun activity as well because we do not cross our arms like this and putting like a palms up because it can be a little awkward position. But those are like a contralateral wiring because we usually do like this. But I guess it's kind of opposite position and try to kind of wiring. And when you not touching, because touching can be easy because you feel those sensation, kind of lift up. But I guess when you kind of point it out, can you wiggle that finger? We just kind of wiggle the different side instead of like that you kind of pointed in area. So this is interesting activities about our brain function. Right brain, right hemisphere, and left hemisphere, we interact each other, but when we do this kind of activity, we can be confused. Our brain can be a little confused. Okay, so far we've been talking about brain and behavior. Did you enjoy this chapter? Yes, very good. So I will, so this next one, maybe I will just kind of show that one. Yeah, maybe I will go to a little bit of this. So this Thursday, we will talk about sensation and perception. So in this chapter, we will talk about fundamentals of sensation and perception, especially how many eyes do you have? Two. But honestly, I'm wearing my contact lenses. So Daniel, you don't need to wear any glasses, and okay, that means you have a good vision.
so far.
Yes, yes, very
It's getting
awesome.
worse.
Because I'm wearing contact lenses when I go back home. I need to take off my contact lenses and wear my glasses. I've been wearing glasses since like a 3rd grade. So imagine my eye power is really not that good, right? So we will talk about those vision and hearing. Hearing, yeah, you do have 2 ears. And some of them, maybe you need some hearing aid. But hearing, we will talk about hearing. And smell and taste. Anybody, you're very sensitive for the, like a taste? Daniel, are you sensitive to the, like a taste?
I would say so. I actually found out, and I'm not 100% sure if this is true, but I found out some people have the bitter taste bud
Yeah.
and some people don't.
Yeah,
And I
yeah.
have the bitter taste bud. So.
And also kind of more sensitive, like a sour taste. And yeah.
Any strong taste.
Yes, yes. So we will talk about smell and taste and other senses. So those are skin senses, those are sensory, yeah, sensation too. So we will talk about those senses. Comparing to chapter 1 and chapter 2, chapter 3 is more like a relaxing chapter. You do enjoy, yeah, you do enjoy the vision function and hearing and smell and taste, yeah. So it will be more like a relaxing chapter. So since we have a couple of minutes left, maybe talk a little bit. Okay, so maybe we will talk more this Thursday. Sensation and perception. Yeah, okay. Thank you. Have a great day. Awesome. So, so this Thursday,